In this problem, we have a train that is traveling at a constant speed of 50 meters per second. And then we have a car. The car has a bit of a lead. The car is ahead by 60 meters. So the car is ahead by 60 meters. And then the car itself at this very point is going at a speed of 20 meters per second. Now the car is basically racing the train and it wants to catch up with the train. The train is going to zip ahead of it. Now what does it do? It needs to accelerate. And the car can achieve an acceleration of 3 meters per second square. Meters per second square. That's the unit of acceleration. What does that mean? That means every second its speed is increasing by 3 meters per second. That's what that means. So its speed is going to keep on rising as it proceeds. Now we have looked at problems where things move at a constant speed, but we have not looked at things where things move under acceleration. So let's get a few basics right. So if d is the distance covered and a is the acceleration and u is what we call the initial velocity, then from Newton's laws of motion and from a little bit of math, we know that the total distance covered in time t equals the initial velocity times the time plus half acceleration times the square of the time. Okay. So this is one of the formulas that we are going to use to crack this problem. So when does the car catch up with the train? So let's just say that the car, again, whenever we have an unknown, we are going to turn that into an algebraic variable. We'll actually call it capital T, is when the car catches up with the train. So in time t, the train would have gone a distance of 50 t. This is in seconds as well. And the distance the car would have gone in the same time, we are going to use this formula now. So u is 20 meters per second. A is 3 meters per second square. So the car would have traveled a distance of 20t plus half times 3 times t squared. Now also note that the car is already 60 meters ahead. So in order for the train and the car to meet, we need the distance traveled by the train to be equal to 60 meters plus the distance traveled by the car in the same amount of time. So notice why this is beautiful. This is beautiful because it turns into a quadratic equation. And okay. All right, now we proceed to solving this equation. In the previous video, we set it up, and now we are going to find out what the solution of this equation is and what it means. So I'm just going to rewrite this equation. If you rewrite it, you get 3/2 t squared plus 20 minus 50t plus 60 equals 0. Now, as you know, I do not like to see this coefficient in front of t squared, so I'm going to multiply everything by 2/3. Okay, I'm going to multiply that whole equation by 2/3. So you get t squared plus 2/3 of minus 30t plus 2/3 of 60 equals 0. So that's t squared minus 20t plus 40 equals 0. So again, we're going to use our favorite technique here, complete the square. Running out of space, so I'm going to write it right here. So completing the square would mean t squared minus 2 times t times 10 in order to get to that 20. I need a 10 here, and now completing the square would mean adding 10 square. So now this is a perfect square. And then I'm going to add 10 squared to the right hand side of the equation as well to balance it out. And then finally, I'm going to move the 40 over to the right hand side. So this is 10 squared minus 40. So that leaves us with t minus 10 squared equals 100 minus 40, which is 60. So now we are in a position to solve this equation. So t minus 10 equals plus or minus square root of 60. Now notice that this actually has two solutions. So t equals plus square root of 60, and square root of 60 happens to be about 7.7. And then there's t equals 10 minus square root of 60. So in other words, t equals 17.7 seconds. And then there is another solution, which is 10 minus 7.7. So t equals 2.3 seconds is also a solution. Why do we have two solutions? What's going on here? So the first solution, t equals 2.3 seconds, is when the train crosses the car. That's when the two have the same position. And then the train zips ahead. The car is still trying to catch up. And then going further down at t equals 17.7 seconds is when the car catches up with the train. So this is how we can set up real life problems and solve the quadratic equation and get a meaningful answer. I hope this inspires you to look at physics and engineering to a greater extent. As a final takeaway, I want you to convert these numbers, 50 meters per second, the speed at which the train is going, 20 meters per second, and this acceleration, into other units, into kilometers and hours, and see if the numbers make sense. Okay? Take care.